Hello, Royals. For lesson 4.6 on the sine law and the cosine law, you should be pretty familiar with these rules. You are not expected to be able to develop the equations, but in general, you won't be given these equations either. So I just want to go through the development of the equations so that if you're in I don't know, an exam and you can't remember what the sine law or the cosine law says, you should be able to figure it out for yourself. First one to look at is the sine law. To do a proof of the sine law, we just start with a general triangle. Sine law is usually reserved for when you don't have a right angle triangle. Using the sine law in a right angle triangle should work, but usually causes a bit of a mess. So let's take a look at a triangle ABC, with side lengths A and B and C. And what we'll do is we'll cut it up into two right angle triangles. And then what I can do is find two different sine ratios. Let's call this the altitude or the height of the triangle. I can say that the sine of A is going to be given by the ratio h over b. And over here, I can say that the sine of B is going to be given by the ratio of h over A. In these two SOHCAHTOA, I guess, primary trig ratios, these h values need to be identical to each other. So I'm going to isolate for h. Here I get that h is going to be b times the sine of A. Here I get that h is going to be A multiplied by the sine of B. Let's call this statement number 1 and statement number 2. And we will set statement number 1 equal to statement number 2. And therefore, we get that b times the sine of A is equal to A times the sine of B. This is a less popular version of the sine law. It's an optional version if you want to use it. Most students usually isolate for either a side length or an angle. Let's just see how that happens. Maybe to isolate for the angle, I'll divide both sides by b. I'll also divide both sides by the sine of b. So what we discover is that the ratio of the sine of an angle divided by the sine of another angle is equal to the ratio of the corresponding sides, like that. Oh, sorry, that's probably not the format of the sine law that you're used to. From here, let's go back to here and say instead, let's divide both sides by, here, I'll just start over. B sine A equals A sine B. Nope. Let's just divide both sides by side length A and divide both sides by side length B. This is probably a more popular version, that the ratio of the sine of an angle divided by its opposite side is a constant in the triangle. There you go. Interesting accidental consequence then is actually looking at a couple of different, less popular versions of the sine law. They are just rearrangements of the sine law, though. Okay. Proof of the cosine law is a little bit more involved, just in sort of the setup, but all we need to do is use some trig ratios and the Pythagorean theorem. So here's what I'll do. I think I'll actually use an origin here. And I'll draw a triangle with a base along the x-axis. Let's call this vertex C, call this vertex B, call this vertex A. That'll give me a side length B there, a side length C there. This entire distance right here is side length A. Once again, I'll drop a perpendicular down here. Let's call this distance x and y so that I have the coordinates x comma y. You could think of it as a point in standard position then, and an angle in standard position. You could even refer to this angle as theta temporarily. What I'm going to do is try to represent x and y in terms of theta so that I can build a Pythagorean theorem on this distance right here and isolate. You'll see how it sort of comes together. So let's just label another point right here. Let's call that, it's called actually the foot of the perpendicular. You'll use this word in calculus and vectors. You have a perpendicular line coming down to a base, and where it hits is called the foot. Let me show you how to reference label diagrams. You're going to be doing this when you're working in 2 and 3 dimensions in a couple of lessons. So I'll say I'm working in triangle CAD. In triangle CAD, I can say that the sine of theta is equal to the ratio of y to b. In other words, y is equal to b sine theta. In the same triangle, I can say that the cosine of theta is the ratio of x to b, and therefore x is equal to b times the cosine of theta. These are called polar coordinates, by the way. At the start of Unit 4, we were drawing angles and finding coordinates of points along their terminal arm. It's actually more popular in post-secondary mathematics to find expressions for the coordinates in terms of the angle. Let's label those coordinates. This will be b times the cosine of theta. This will be b multiplied by the sine of theta. And now I'm going to work in triangle ADB. In triangle ADB, this distance right here, actually let me start with the formula. This distance right here is going to be the difference between a and x. That'll be a minus x. So we start with a Pythagorean relationship on these three sides. The square of c is going to equal the square of y plus the square of a minus x. Let's substitute in, call this statement number 1, statement number 2. Maybe I can just say I'm going to substitute in statement number 1 and statement number 2. And that'll give me c squared equals the square of y, that's b times the sine of theta squared, plus an a minus an x, and where I see x, I'll write b multiplied by the cosine of theta. And I'll mention again that this proof is not going to be asked of you at this course level, but if you've been able to follow it up until now, you're in decent shape. Even if you were confused, I'd like you to maybe pause the lesson and try to expand this and see what you can do. See if you can simplify this expression. It'll be a good practice of a couple of lessons that we've already seen. So I'm going to start tidying up here. I'm going to keep c squared. I kind of know what my goal is. I'm trying to prove the cosine law. But I should also be able to discover this here. I'm going to square b sine theta. Well, the square of b sine theta, this would be b sine theta multiplied by b sine theta. It's 2 factors of b sine theta, which means it's 2 factors of b and 2 factors of the sine of theta. This right here, shall we maybe take our time on this and write it out carefully? Because we don't want to accidentally try to distribute an exponent. Exponents aren't distributive through sums and differences. That'll just give me an opportunity to sort of see all of the distributions here. Let's do this a multiplied by that a. That's going to be 2 factors of a. Then I'll have a negative 1ab cos theta. Negative 1ab cos theta. Then I'll have a negative b cos theta times an a. That's going to be another negative 1ab cos theta. Multiplication is commutative. It does not matter in what order I multiply. So I choose to write it in an order that makes it look like terms. And a negative 1b cos theta multiplied by a negative 1b cos theta is going to be a positive b squared cosine of theta squared. Okay. Let's do some tidying up here. Let's write b squared sine theta squared next to the other b squared term, cosine of theta squared. Let's collect the I think I just misplaced it. It would have been nice to start with that a squared there. I'm not going to try to squeeze it in. So I'll write the a squared there, and then I'll collect these two terms. A negative 1 ab cos theta minus a 1 ab cos theta is going to be minus 2 ab cos theta. Okay. So far we have, from the development, if you can follow it from there, we've just been expanding and dealing with algebra. Review of grade 9 and 10 algebra. Okay, so to get things to line up into the formula that we want, on this step, I'm just going to put that a squared first. What about this b squared sine theta squared plus b squared cos theta squared? Let's use a familiar and useful tool of common factoring. There is a common factor of b squared. Now, there's more than one way of proving the cosine law. I've chosen this way for a specific reason. Minus 2ab cosine of theta. And that's because we get an opportunity to review the Pythagorean identity. If you saw proof of the cosine law in grade 10, it was probably not this one, because you probably weren't told that the sine of theta squared plus the cosine of theta squared was 1. And even if you were, I don't think I would have trusted someone who just told me that. I trust someone who shows me that. So there's b squared multiplied by 1, and here's minus 2 ab times the cosine of theta. Let's rename theta. Another name for theta in this triangle is the angle C. I guess I could have just used the angle C the entire time for the proof. So these are your choices. You will not be given a formula sheet in this course. So once in a while, some hints about formulas show up in multiple choice questions on the exam. So for the sine law and the cosine law, you either want to know these laws or you want to be able to prove them on the spot. I don't think you want to prove them on the spot, so this will be one of the rare cases that I suggest you memorize this formula, just like you have memorized the Pythagorean theorem. And that's a decent place to start off with. The cosine law works in a right-angled triangle, just like the sine law will work in a right-angled triangle. But using the sine law or the cosine law in a right-angled triangle is like using a chainsaw to cut a piece of paper. It's the wrong tool for the job.